Hey everybody. So today I wanted to take this opportunity to solve a parallel resistive circuit using Ohm's law and Kirchoff's current law. So here on the board I have drawn a 3-branch parallel resistive circuit. Branch 1 contains a resistor that has the value of 5 ohms. Resistor 2 is 10 ohms. Resistor 3 is 12 ohms. Our supply voltage for this circuit is 120 volts. So in a parallel resistive circuit, the supply voltage would be the constant variable. So E total would equal the value of voltage across resistor 1, which would equal and be the same value of voltage across resistor 2, which would then be the same value of voltage across resistor 3. Electrically, this point is the same as this point, and this point is the same as this point. And that is consistent for each branch that is added to a parallel resistive circuit. So voltage is your constant. Let's next move on to resistance total. Resistance total in a parallel circuit is solved with a reciprocal formula or an inverse method. It looks like this. For every resistor that you have added to a parallel branch, you would add it reciprocally or inversely, which is included with the ones being inversely added into the formula. So for this specific circuit, to apply the formula, it would look like this. So 1 divided by R1, which is 5 ohms, plus 1 divided by the second branch, which is 10 ohms, plus 1 divided by 12 ohms. This gives us a resistance total of 2.61 ohms. In a parallel resistive circuit, the resistance total is always less than the smallest branch of resistance in the circuit. So in this specific circuit, resistor 1 has 5 ohms of resistance, and our resistance total has come in to be at 2.61, which is significantly less than 5, which is a good indicator that we have used the formula appropriately. So now that we have a resistance total, we can move forward to find the current that's flowing through the circuit using our Ohm's law formula. So the formula for Ohm's law and circuit total is I total equals E total over R total. So the E total is our supply voltage, which was given at 120 volts. We're going to divide that now by the resistance total that we just solved, 2.61 ohms, and that gives us a current total of 45.98 amps. So in the circuit, we have an incoming current of 45.98 amps. In a parallel resistive circuit, Kirchoff's current law dictates that the amount of current flowing through the branches will equal the applied or total current. So the amount of current flowing through resistor 1 could be added to the amount of current flowing resistor 2, which would then be added to the amount of current flowing through resistor 3, should give us the 45.98 amps to prove that Kirchoff's current law is in fact true. So we're going to further use Ohm's law to solve the value of current that is flowing through the branches, and then in essence prove that Kirchoff's current law is true. So the current that is flowing through the first resistor can be found using, so IR1 equals VR1 divided by R1. Voltage, again, is constant. The value of voltage across resistor 1 is 120 volts. Divide that by 5 ohms of resistance, gives us 24 amps of current. We'll do the same now across the second resistor. So again, 120 volts is the constant, divided by the resistance of the second branch, which is 10 ohms. And that gives us a value of 12 amps of current. And then we would apply Ohm's law again to the third branch, IR3 Source voltage, again, constant across the branches, 120 volts divided by the resistance of that specific branch, 12 ohms of resistance, which then gives us a value of 10 amps. So Kirchoff's current law states that I total equals IR1 plus IR2 plus IR3. So if you take the individual branches, so current through the first branch was 24 amps, plus the current through the second branch as solved using our Ohm's law formula, plus the current in the third branch, you would find that Kirchoff's law is true. This gives us an I total of 46 amps, which is what we had originally solved using our Ohm's law, I total equals E total divided by resistance total. So let's just recap the variables and the rules that govern a parallel resistive circuit. So voltage in a parallel resistive circuit is your constant value. The resistance total of a parallel resistive circuit is added inversely or using the reciprocal method. Therefore, the value of resistance in your parallel resistive circuit, the smallest branch, the resistance total will be less than that value. And the current is additive through the branches. So Kirchoff's current law is true in a parallel resistive circuit. The sum of the current through the branches will equal your applied voltage. Thank you.